SciAnts. We get experimental science. We're curious, non-judgmental.
So, hi everybody, I'm Mallory. I am an assistant director of foundation relations here at Fred Hutch. But before I landed here, I was a scientist. First and foremost, I got my PhD in biochemistry and molecular biology at University of Kansas Medical Center. I was a protein biologist, also an X-ray crystallographer and structural biologist by training in DNA damage. There I was a science policy manager for the American Society for Biochemistry and Molecular Biology. That's a mouthful. They call themselves ASB&B. They're a great society of biochemists and molecular biologists, and I was able to represent their interests to Congress, to National Institutes of Health. And while I was there, I was particularly passionate about supporting the next generation of scientists and making sure that they have the resources and the skills that they need to be great scientists themselves going into their future careers. So that passion of mine has persisted through my volunteer work with the National Postdoc Association, and also kind of led me into this role here at Fred Hutch.
And then you mentioned too you're into science policy and like being able to continue the science advocacy. But what all does that entail?
I would go to like the Hill in DC and speak with congressional offices about supporting like the funds and appropriations for basic science for National Institutes of Health. But I also would advocate directly to the National Institutes of Health to try to get them to improve their policies.
Nice. That's amazing. We actually, a similar question. So I was on the Hill in March doing some advocacy as well for just like increased funding for NIH and NSF. And one issue that we ran into is always coming across the aides, not actually the lawmakers themselves. Did you find yourself like having those kinds of difficulties as well, or did you feel like you had more access?
We had the same experience. So it's quite common. You're going to probably get a legislative aide or a legislative director actually in the room with you. Of all the times I was on the Hill, I met with a congressional member twice. So yeah, not that often that we actually met with the member, but honestly, you can have better conversations with the aide most often and the legislative director because they have a little bit more deep-rooted knowledge in kind of what's going on with NIH, with NSF, to be able to have a more productive conversation about what you need that they can then translate to the congressional member about, you know, what bills or what appropriations that we're recommending. So they can plug it in where it most makes sense to their member, but they actually understand what we're saying too. So I found that although you aren't meeting with the member, it's still a more productive conversation with that legislative director and aide.
Nice. Nice. I'm glad you had that experience. I did not. Tickets to get on in. And I guess, Mallory, tell us a little bit about your time at the Hutch. What do you do there?
Yes, I would love to. So, as an assistant director of foundation relations at Fred Hutch, I help secure resources for Fred Hutch through philanthropy, through foundations, and through national organizations and societies like ASB&B that I used to work for. So, a lot of foundations and a lot of organizations have grants that scientists can apply for, and these grants come into the university as a grant mechanism. There's some kind of contract between the organizations, but you can also kind of think of them as philanthropic supports from a different entity that's coming to Fred Hutch to support research. So my job is to help inform the Fred Hutch researchers that, hey, look, there's this grant application that you can apply for to support your research and create awareness around those opportunities, but it's also to help the scientists apply for those opportunities and make sure that they're putting forward applications that are really competitive. So I spoke a little bit about how I'm really passionate about the next generation of scientists and that work continues in this role. So I created kind of a specialty for myself in helping postdocs.
Nice. It would have been amazing to have you when I was a postdoc, because mine was just like, I was like, oh, I know about these postdoc applications, so let me just submit. And luckily I was able to actually get a cancer one, a Damon Runyon, as well, and I had for actually gut tumor genesis in insects. So it's a similar but different organism that we were looking at, but similar idea of it too. It's a huge job that you do. It's like for the future of these researchers, because for the chat, if you have a history of funding that you've gotten yourself as a postdoc or a grad student, you're more likely to be able to get a research position elsewhere, like if that's what you want down the line. And it's never straightforward, never easy. So it's a huge job that you're doing to help people, especially on that grant writing side of things, which is not an easy skill, one that we tend not to learn either.
Exactly. We're as a scientist in the weeds. We're thinking about things in such a level of detail that you don't need in a grant application. You don't need to talk about all the different types of experimental pieces that you're putting together in your experiment. You just need to explain the bigger picture. And also how to write scientifically in grants is different than papers. Like papers that are very technical, and grant writing is a lot more selling the science. You write a little bit more actively, and there's certain even like grammar differences that you think about in writing that you apply in grants than in comparison to papers.
Yeah, absolutely. It's like, how are you going to change the world versus what equipment do you need to do a particular experiment or anything like that. So yeah, what is, Mallory, some of your favorite science being done at the Hutch? And again, I realize even if it's all DNA damage, that's okay. Whatever you think is cool.
Let's get into it. Okay, so first let's talk about sarcomas. So sarcomas are a type of cancer that come from connective tissues. So they're actually quite rare as a type of cancer. And I'll also add, just for context, that when we talk about rare cancers, actually 1 in 5 cancers are considered rare. So when you group together all the rare cancers, it's actually a lot of the cancers that are being diagnosed. And these are, again, hard to find treatments for because they affect fewer people and are less marketable to industries to build up new drugs that feed into the pipeline and reach patients. So this is definitely a high area of need. And we have a researcher here on campus, Taran Gujral, who has launched a rare cancer research effort called Tracer. He explained to me about his work with Tracer, and my jaw hit the floor. It's incredible the work that he is doing there. He is able to he has this drug matching platform, and it uses artificial intelligence to help suss out safe pre-approved therapies that can be repurposed for people with rare cancers.
That is amazing. So these are treatments that or drugs that are not designed necessarily for that tumor or that cancer type, but using the AI, it's like the off-label use.
Exactly. Yeah, you nailed it there. It's already FDA pre-approved for, let's say, breast cancer, for prostate cancer, but using AI, they can figure out this drug or maybe even a combination of 2 other correlated drugs happen to come together and work perfectly for your specific cancer. So it's kind of a blend between personalized medicine and, these very rare cancers. The pharma group that owns that drug probably doesn't want to put a bunch of money into labeling it and marketing it for only 100 patients across the nation. They certainly will publish it and make sure that any other oncologists know that this could be a potential option. But as far as labeling it, it's hard for me to say, but I would imagine no. So seeing that we have not a ton of time left together, I thought I might pivot and kind of look at infectious diseases from the other side of cancer. So cancer patients are often immunocompromised. They're going through chemotherapy, their immune systems, they get shut down because your bone marrow and your immune system are in large part rapidly dividing cells that are getting targeted by these chemotherapies. So these cancer patients are often very susceptible to infections. And this is a huge kind of area that isn't being fully explored. It's an underfunded kind of aspect of the research. And of these patients that are immune compromised, especially those from bone marrow transplants, a third of them acquire respiratory viral infections within 6 months. And then a third of those actually go on to progress into the lower respiratory tract. And once it does that, it is very hard to really treat it at all. And 40% of those patients die within 3 months. So there's this kind of progressive evolution of the side effects of chemotherapy and these secondary infections that go on to cause potentially death. Pretty awful to go through chemotherapy and then succumb to an infectious disease. So we have this researcher on campus, Dr. Jim Uniyaratanakornkit. Had to practice that one, but an amazing researcher here at Fred Hutch who developed this antibody cocktail that can block common respiratory viruses from infecting these immune-compromised patients. So the really cool thing that he did is he made these kind of Frankenstein antibodies. So it turns out that there is a kind of rule that you can't infuse so many antibodies into a patient at one time. There's these protections for the patient, and that way they were kind of limited in the antibodies they could use to try to protect against all the different types of respiratory infections that there are. So what this researcher did is, so first he filtered for HPIV3, found all the cells that target that, and then he took those 900 cells from 200 million, we're down to 900 cells, and he exposed those to HPIV3 to see which one of them could also fight HPIV. And he found 2 cells that made antibodies for both infections.
Wow.
Capable of fighting both infections, and just out of pure luck was able to replicate and grow up these cells to produce these kind of Frankenstein antibodies. And then he did the same process with 2 other type of respiratory viruses, and now he has a cocktail of 2 antibodies that target 4 different respiratory tracts that is showing effective in preventing infection for these viruses in immunocompromised hamsters.
Oh, that's an interesting model.
I thought so too. So I did look a little bit further into why hamsters. So I do have a little bit of a thought on that. So turns out hamsters more accurately mimic human disease progression for infectious and pathogenic diseases. Not exactly sure why, but turns out hamsters do, and they have more genetic diversity compared to mice, which are, usually inbred and very controlled environments. So I guess a lot of infectious disease researchers like to use hamsters as a model.
I wonder if it's more representative of a bigger population with that genetic variance. And
yeah,
depending on cancer type. And then Ms. Capri.
That's the thing with cancer. It's like everything is just, it's hard to even call one thing cancer because they all have their own facets, their own uniqueness to them that makes cancer so hard to treat.
Which is why I think it's also remarkable, again, that AI that we were talking about earlier of that personalized treatment, right? That's, I think, if we can translate that to many, many more avenues and the cancer treatment alone, like that would be a phenomenal breakthrough to be able to have, like, applying it to this kind of treatment to, like you were just saying, like the searching out for in those dormant cells, like, what maybe apply it to, like, in combination with these drugs, like how to hit which kind of dosage of this new drug to do, and like everything else in between. It's like they're all kind of linked together in really, really powerful tools.
If you could think in the future, like let's say you show up with metastatic cancer in 9 distal sites, like you could take the original tumor, those 9 distant sites, 10 samples, give it potentially to the system, and they find a cocktail that works against all of them, works against, here's a drug for these 3 and here's the drug for the rest. Can it create a cocktail that just kills all of them? I don't know, but I think that's where we're headed.
Absolutely. It's so exciting to be able to be on that front line, and like hear about it from y'all is just it's a very inspiring chat that I think we're having, is like all the positives coming out of it. What would you like to leave us with? What would be like a final inspirational word maybe that you'd like to leave us with?
I would say that it takes a village. When I think about the mission here at Fred Hutch to cure cancer, it requires all of us. It requires the people at Fred Hutch doing the research at the bench. It requires all of us to support those that we know in our lives that have cancer. It requires, just this community approach to fighting cancer, supporting cancer patients, supporting cancer survivors, that we all have a part that we can play in fighting cancer. And I just encourage everyone to do your part in fighting cancer. You being here and supporting this dream is already one step, and again, appreciate all of your guys' support, and let's all just continue playing our part in fighting this awful disease.
I think that's a beautiful note. Very well said. Thank you so very much, Mallory, for being on with us. Thank you so very much.
You guys rock. Thank you so much for having me, and hope to see you guys again soon.
Thank you, Mallory. Have a good one.